Hello. Hello and welcome to this video. As discussed in previous video, we'll go through range and multi-range functions and operators. And once we are finished with the theoretical side, we will look at the example. So first we'll finish the theory and then we'll see the example. So without further ado, let's get started. See section 8.17 for an overview of range types, which we have already covered. Table 9.58 shows the specialized operators available for range types. Table 9.59 shows the specialized operators available for multi-range types. In addition to those, the usual comparison operators shown in Table 9.1 are available for range and multi-range types. The comparison operators order first by the range lower bounds, and only if those are equal do they compare the upper bounds. The multi-range operators compare each range until one is equal. This does not usually result in useful overall ordering, but the operators are provided to allow unique indexes to be constructed on ranges. So first range operator is at the rate greater than. Like arrays, it takes two ranges and it checks whether the first range contains the second. So int range 2, 4 will contain int 4 range 2, 3. Then we have the second function, any range at the rate greater than any element. So it checks whether the range contains the element. So for example, we have timestamp TS range 2011 1st of January and to 1st of March 2011. Does it contain 10th of January 2011? And the answer is true. Similarly, we have any range less than at the rate any range. It checks whether the first range is contained by the second. And we have the example 2, 4, and on left hand side and on right hand side we have 1, 7, which is true. Similarly, we have any element less than at the rate any range, which checks if the element is contained in the range. So 42 is not in the range 1 to 7, so it is false. Then we have any range ampersand any range, which checks do the ranges overlap, that is, have any elements in common. You see that range 3, 7 has elements in common with range 4 to 12, which would be 4, 5, 6. So that is true. Then we have any range less than any range. So it checks whether the first range is strictly left of the second range. And you see that 1 to 10 is in the left of 100 to 110, so it is true. Similarly, we have greater than, which checks whether the first range is strictly right of the second. Then we have ampersand less than, which checks does the first range not extend to the right of the second. So here first range does not extend to the right of second, so it is true. Then we have ampersand greater than, does the first range extend to the left of the second? So 720 extends to the left of the second. So yes, it is true. So now you have to see that you can't remember all this all the time. Okay. So the point is not to memorize it, but to be aware of what it is. Okay. Then we have two range comparison where we have minus, minus, which checks whether the ranges are adjacent, and 1.1 to 2.2 is adjacent to 2.2, 3.3. Then we have any range plus any range, which computes the union of ranges. The ranges must overlap or be adjacent so that union is a single range. We'll see this in range merge also. Then we have any range star any range, which computes the intersection of the ranges. So 5, 15 and 10, 20 will give a range of 10, 15. So always remember that these ranges are half open, half closed and half open. On the left side, these are half closed. That is, it includes the value of 10 here. And on right side, it is open, so 15 will not be included. The values contained here are 10, 11, 12, 13, 14. Then we have any range minus any range, which computes the difference of the ranges. The second range must not be contained in the first in such a way that the difference would not be a single range. So from 515, we subtract 10 comma 20, we get 5 comma 10. Then we have multi-range operators. We have any multi-range at the rate greater than any multi-range, it returns a boolean. It checks whether the first multi-range contains the second. So similar to previous one, it works in the same fashion. And most multi-range operators will be similar. So similarly, at the rate greater than operates on any multi-range and any range, checks whether the multi-range contains the range. Any multi-range at the rate greater than any element checks whether the multi-range contains the element. So you can look at the examples. Any range at the rate greater than any multi-range, does the range contain the multi-range? Any multi-range less than at the rate any multi-range is the first multi-range contained by second. Then we have any multi-range less than at the rate any multi-range, which checks is the multi-range contained by the range. Then we have any range less than at the rate any multi-range, so it checks whether the range is contained by the multi-range. We have any element less than at the rate multi-range, which checks that whether element is contained by the multi-range. So I'm not reading all the examples because these are similar to range functions. Then we have ampersand, which checks do the multi-ranges overlap, that is if they have elements in common. We have any multi-range, ampersand any range, which checks whether the multi-range overlaps the range. We have any range, ampersand any multi-range, which checks the range overlap with the multi-range. We have any multi-range less than any multi-range, which is similar to range example. Then we have multi-range with any range, same operator less than. Then we have any range on left hand side less than any multi-range. If these are similar, and we have any multi-range greater than any multi-range, any multi-range greater than any range greater than any multi-range. So these have similar semantics that we have discussed with any range or other range actually. Then we have any multi-range ampersand less than any multi-range. Does the first multi-range not extend to the right of second range? Any multi-range ampersand less than any range. Does the multi-range not extend to right of range? Similarly, we have left side and right side of this. Then we have adjacent operator for multi-range and any range on both sides. And then we have union with plus. Okay. So union is with plus, and then we have star, which computes the intersection of multi-ranges, and minus, which computes the difference of multi-ranges. So I'm deliberately not going through everything because it is similar to the any range. So if you're interested in reading the description, you can pause the video and read it, or refer to the documentation PDF from the PostgreSQL website and read it. The left of or right of or adjacent operators always return false when an empty range or multi-range is involved. That is, an empty range is not considered to be either before or after any other range. Elsewhere, empty ranges and multi-ranges are treated as the additive identity. Anything union with an empty range is itself. Anything minus an empty value is itself. An empty multi-range has exactly the same points as an empty range. Every range contains the empty range. Every multi-range contains as many empty ranges as you like. The range union and difference operators will fail if the resulting range would need to contain two disjoint subranges. Such a range cannot be represented. There are separate operators for union and difference that take multi-range parameters and return a multi-range, and if they do not fail, even if their arguments are disjoint. So if you need a union or difference operation for ranges that might be disjoint, you can avoid errors by first casting your ranges to multi-range. Now we will look at table 960, which shows the functions available for use with types, and table 9.61 will show the same for multi-range. So first we have lower, takes any range, extracts the lower bound of the range, null if the range is empty or has no lower bound. So 1.1, 2.2, this range has the lower bound of 1.1. Similarly, upper will use the upper bound. Is empty, will check whether the range is empty or not. Lower inclusive, is the range's lower bound inclusive? So 1.1 is inclusive. Then we have upper inclusive. So usually, as I said, it is open on the right side. So upper inclusive will be generally false. Lower underscore ends, does the range have no lower bound? A lower bound of minus infinity returns false. So here we have an empty range. So you see lower infinity, lower inf is true here. Upper inf is similarly true here. Range merge will compute the smallest range that includes both of the given ranges. So 1, 2 to 3, 4 will give you 1 to 4. Then we have multi-range functions like lower, like range, we have lower and upper bounds. So similarly, we have SMT, lower inclusive, upper inclusive, lower infinite and upper infinite, and range merge. And then we have multi-range from any range, which returns a multi-range containing just given range. And unleashed takes a multi-range, expands a multi-range into a set of ranges in ascending order. So the example is given here. And with this, we come to the end of range and multi-range. And the next video will be on the example. And then we will proceed and look at the aggregate functions. Now, aggregate functions are quite interesting. And after that, we will have window functions, if I remember, window function, yeah. So in the next video, we will finish the aggregate functions, and then we will proceed to examples of aggregate functions. Okay, and that's how we will continue. Theory and practical, we combine both. So I hope that you have enjoyed this. Now, one thing I wanted to say is that if you look at the beginning of range discussion, because we went quite fast, section 8.17 covers the range types. And I have previously created a video on chapter 8, entirety of chapter 8 we have covered. So you can look for the video on range in my previous videos. In the playlist, you need to look at the playlist and you will find it. And you need to go through that. I should have said this in the beginning, but I forgot. So once you read that, you should follow that with this. You should not study the functions and operators with this. So with this, I will end this video. But before I end, I will show you my question answer website. It is kunjika.astaoka.org. And I'm trying to build a community where we can learn and share our knowledge with each other. So if you have questions related to SQL or PostgreSQL in general, you can come and ask using the tag SQL, and I will try my best to answer your questions. No guarantees. And if you are an expert of SQL, then please help by answering question of others. So with this, I will end this video here, and I hope that you have learned something useful. And we will meet tomorrow with another video on PostgreSQL with the example of range and multi-range. So till then, you stay curious, keep learning, and most importantly, enjoy.